In this video, I'll construct a confidence interval for a population mean when sigma is unknown. The problem says you randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit. Construct a 95% confidence interval for the population mean temperature of coffee sold. Assume the temperatures are approximately normally distributed and the sample standard deviation is 5 degrees Fahrenheit. So sometimes it's difficult to tell whether you should use a t distribution or a z distribution. The key thing to look for is, have they provided us information about the population standard deviation or not? One of the key things here is that they had told us the sample standard deviation without telling us the population standard deviation. Nowhere in the problem do I see information about the population standard deviation, the sigma. So with that in mind, I definitely want to use a t distribution here. Now you may notice that the number of coffee shops sampled is actually less than 30, and that should raise a red flag as well. However, notice that the temperatures have been claimed to be approximately normally distributed. With that in mind, we actually can use the steps that are listed above. If we wouldn't have been able to, if our distribution had not been approximately normal, if it had been something else that was unknown, then we couldn't have used this approach to finding a confidence interval. But now we know that we can. So let's go ahead and do all the steps that are necessary to create the confidence interval. On the side, I'm just going to write down the givens for reference. N is 16. The population standard deviation was never given. So we will actually use the next best thing, which is the sample standard deviation S. And that was 5. They gave us a sample mean, which is nice because sometimes you have to calculate it yourself if you're taking the data yourself or if just a listing of the data is provided. Here we know the X bar, that's good. We know the confidence level, 95%. And that looks to be everything that's given. What we need next are some things that we have to figure out on our own. One of them is going to be the degrees of freedom. Now remember, that's got the formula n minus 1. Our n is 16, so our degrees of freedom is 15. We also need to figure out what is going to be our TC. So let's go ahead and go to the tables. That's where we find the TC. Remember, we have a degrees of freedom of 15. And we want a 95% confidence interval. On the left-hand side, we can find degrees of freedom of 15. Here's our 95% confidence level. Intersect them, and you get 2.131. Okay, at this point I'm going to go ahead and start to sketch my curve. Now let's put our TC values down. We're going to have 2.131 and negative 2.131. This is the TC, and this one's the negative TC. Okay? TC, negative TC. We'll trace those up until we can intersect it with our interval above. And this shaded region represents our confidence interval. It's going to be centered around the sample mean of 162. And our last job here is to find out what the margin of error is. Now, last video, we had used a formula which had used ZC times population standard deviation over the square root of n. In this approach, we're going to have TC times the sample standard deviation divided by the square root of n. That's a major difference here. So, we'll have 2 we'll have 2.131 times 5 over the square root of 16. It's 2.66. Now what we want to do is we want to add that margin of error to the x bar. You get 164.7. Now we want to subtract our margin of error from x bar. And that comes out to 159.3. Now our confidence interval is complete. And we can state that with 95% confidence, the population mean temperature of coffee sold is between 159.3 degrees and 164.7 degrees.